In this video, we shall discuss about the pointers. So, in order to understand what pointers entail in programming, let us start by asking some basic questions. The first question would be, what are the pointer types? The answer to this question is pointer types refer to variables that store addresses of computer memory or RAM instead of storing data such as numbers, characters, or strings. Remember, we have been dealing with integers, which are data of numeric type. So, pointers do not store numbers such as 2, 3, 4, or 5. They just store the memory address of the computer. Now, another question would be, how are pointer types declared? The answer could be, pointers are declared by the aid of indirection operator, which is symbolized by a star. You will remember, when you are declaring an integer, you just write the keyword int and then space followed by the identifier, which could be a character like A, B, or C. But when you are declaring a pointer type, you'll have to write first int and then space followed by identifier, maybe C, but then before the identifier, there should be a star. We shall see this when we look at a read program in the computer. Another question would be, how are addresses stored in variables? Well, addresses are assigned to variables through address operator, which is this symbol here, that is the ampersand. Fine. After those basic definitions, let us now look at the worked example, which is a program that manipulates pointers. So line number 1, 2, 3, up to 4 are lines which we are already familiar with, and our program ends at line number 16 with this closing curly bracket. So at line number 5 is where we see something different. Int y, this is a familiar situation, but int x, int star x is not familiar. You can see now the difference between int y and int star x is that int y is the type space identifier. Here is the type space star identifier. This is a pointer type. This variable will store an integer like 4, 5, 5,000. This particular variable x will store an address of a variable like y. We shall see. Enter an integer. This is just a message as usual. But here now, we are capturing the value that is being captured from the keyboard, and it is inputted in variable y. At this line number 8, x is assigned the address of y due to this ampersand symbol, which is the address operator. Here, it is not y which is being assigned to x, rather, it is the address of y which is being assigned to the variable x. This is possible because x is a variable which will hold the address of an integer type variable. Now what follows here, line number 9 to line number 15, are just output in order to see what is inside the computer for what has happened earlier. Now here we are accessing data in y, variable y, using the identifier y. That's why we are saying here, cout y. We shall see what is in variable y. If we had put 7 in variable y, at this particular line, would see 70. Here we are accessing data in variable y using identifier x, cout star x. We shall see 70 as what we saw here because we are accessing data in y using variable x by the aid of indirection operator. This is a message looking into variable x. What is in x? Remember that in x we assigned the address of y. So we shall see the hexadecimal value, which is the address of where y as a variable is. And here we are going to see out. This is just a message, sorry, but here is where we are going to see that particular hexadecimal value, which is the address of y that was assigned in x. In order to understand better this particular phenomenon, let us now go and see a running program. Because we are using the three-tier approach, now let us try and see what is happening inside the computer. This is the program that we have just discussed on the PPT slides. Include using namespace int main. Here we have int y, int star x. So these are variables that have been declared, but here this variable is a pointer variable because it is presided by this particular operator. Now, at line number 8, data is being entered into y. At line number 9, the address of y is entered into x. And now, at line number 11, we want to see what is in y. At line number 13, we want to see what is in y using x, and here we want to see what is in the variable that is pointed to by x, and the variable pointed to by x is y because the address of y is already in x. But here at line number 15, we want to see inside x what value is there. It means this value which was assigned to x will now be revealed here. So let us compile and see how this program will behave. We are running it. Message comes, enter an integer. I'm entering that number 6754. That will go into y. So now accessing data in y using identifier y, here is cout y. The effect of cout y is 6754. But here is accessing data in y using identifier x. Here is cout star x. We are seeing the same data that was inputted in y. Looking into x, here it is cout x without a star. So we are seeing 0x61fe14. This is the hexadecimal address where variable y is stored. So if we come here, for example, and we declare another variable of type, of pointer type, let's say int, and then we say star w, and then we come here and we say, for example, cout w. Sorry, we cannot say that. We have declared w, but let us now declare another variable. We call it p. Let's say int p. And then let us say now we input data into p. Let us say p equals to 7. This is okay. But then we can now say, for example, that W, which is a pointer type, we assign it the address of P. Sorry, we will have to use the ampersand. The address of P is now assigned into W. And now here we want to see, if we say here end L, end of line, in order to visualize properly, then C out W, we want to see the address of P which has been assigned to W. We have modified a bit of our program in order to appreciate how hexadecimal values are stored. Let us compile this program, and it doesn't show any error. Let us run it. After running, we shall see the usual message, enter an integer, and that one. Now, just take a look here, looking into variable x. This is the new value of x, but then 0x61fe0c. This is 0f61 fe08. These are hexadecimal addresses. So this is the location of y, and this is the location of p. And the location of y was put into x, and the location of p was entered into w. And you can see these values are quite different, but that is how you can see the way we simply manipulate the addresses of memory, computer memory. Let us now go to the third tier, whereby we shall discuss this example using visualization, that is RAM diagrams. Now, before the beginning of the program, normally this is what RAM looks like. There is an address here, 0x1, sorry, x02 is x, sorry, this is x03, this is x04. These are hexadecimal addresses, and that is the computer RAM. This is the computer RAM. That is before the running of the program. Now, when the declaration line is encountered, int y star x. So you have declared two variables here, int y and int star x. What happens in the computer RAM? So the computer RAM will change, and the memory addresses are the same. That is x01, x02, x03, x04, x05, for example, and so forth. But now, because of int y, this one will be called y, and it is reserved. Because of int star x, this one will be called x, and it is reserved. So this one is free. This is free. That is because of this declaration. Now, suppose the computer encounters cin y, and at this line, if you input, let's say 45, you write 45 on the keyboard, the memory will change. And what is going to happen is this: we shall have x01, x02, x03, and x04, for example, and x05. Then the reserved y, which was a reserved variable here, will receive data, let's say 7. when you put here. But then when the computer encounters the line that x, which was declared here, equals to ampersand y, what the computer does is that it comes, this was y, this is x. Now variable x is receiving the address location of y. The address location of y is this one here. So x01 will come there. The content of x now is the address of y. So this is what happens when such line is encountered. Now when you write cout y, then the computer will output the value of y on the screen, which is number 7. But then when you say cout star x, the computer will come and see where is x pointing to. X is pointing to x01, which is this location where the 7 is. So the computer will reveal number 7. But when the computer encounters cout, sorry, this one must be there, cout x, now there is no operator, the computer will come and look into x, and what you are going to see on the screen is x01. That is the address or the content that is in x. So in short, this is the visualization of what is happening in the computer, or the behavior of the program that we have just written. And this one marks the end of our discussion concerning introduction to pointers. Thank you.